next speaker is Martin Hennemann of IDS, and his presentation is on the topic of the new easiness of AI vision with IDS NXT. The floor is yours.
Thanks a lot. So welcome from my side to our session. I'm Martin Hennemann, working at IDS in product management. And I will talk about you today mainly on our NXT AI vision platform. But I will start with a short introduction about who is IDS. So IDS was founded in 1997, so 25 years ago, about 50 kilometers north from here, close to Heilbronn. And since then, there we develop 2D industrial cameras, and we supply the world of vision, as assembled here, with industrial components for machine vision. Right now, we have about 350 people, mainly working there, but also in our international sales offices worldwide. So our product portfolio starts on the left-hand side with our 2D industrial cameras, our UI brand, that which we grow up with since 20 years, almost 20 years soon. And then on the right-hand side, since 10 years, we grow in the 3D area of machine vision with the N-Sensor cameras. And today I want to focus on the central part of our product portfolio, that is the IDS NXT AI vision system. So what is IDS NXT? So Edge AI vision means we have a camera platform that is able to run inference tasks at the edge. So that is our Rio camera here. Internally, it has our deep ocean core that is able to do deep learning inference. Around that, this platform offers industrial interfaces, transneural networks. We provide a number of easy-to-use tools, which I will go into today. And we also have a vision app concept on the hardware. That means basically you pack your functionality into an app and you transfer it to the camera, and you can have different apps running there at the same time or in sequence. As for the hardware platform, on the left-hand side, you see our current lineup. These are industrial cameras with processing inside in IP30 or IP65-67 ingress protection classes. And on the right-hand side, this is the new thing for the Vision Show. On our booth right there behind you, you see our new hardware platform, which brings more performance to deep learning and other vision tasks on board. As for the deep learning technologies that we offer, so we offer classification tasks that answer the question whether the image shows a certain kind of nut or another. We offer object detection, that's for finding and tracking objects in the image. And also new as a prototype, we show on our booth here the anomaly detection technology that answers the question whether the image content is a normal, what I want to see, or there's something anomal. And the interesting thing here is that you only train the normal, and you can then even differentiate unknown errors when looking at it. So that's our technology and hardware portfolio. This is brought together by our sample workflow. So generally, when you do a deep learning application for vision, you start with grabbing image data, you do a labeling process, go training the CNNs that you need, and then you run the AI on our device. And so this is covered by our easy-to-use tools. We have, of course, on the left-hand side, we have a cockpit that is for the grab process. You enable, basically, you channel your images, you give them already label at that stages, give them labels at that stage, and you channel that together so you have a meaningful data set. Then for labeling and training, we offer a cloud-based AI vision studio called IDS NXT Lighthouse, hosted on AWS or on Azure, depending on your preference there. And this you can use to bring together your data set and train your neural network. And then deploying, of course, as I shown before, our hardware platform of the IDS NXT cameras with a new flavor coming out soon. There is another part to this, that is AI does not stand alone, so having an inference result is very nice and very ideal here. You can have it very fast on the camera. However, beyond that, you usually have some logic that you want to do. So today I want to focus on how to create vision apps. From an integration perspective, we can look at IDS NXT like this. So we have a shop floor where machine vision is needed to do a certain kind of task. On this shop floor level, our IDS NXT hardware operates, and it interfaces directly to a control. The included web server also provides some HMI if needed, and as mentioned with the Vision app concept, you can provide different kind of tasks, functionalities, and interfaces via plugins or Vision apps. So the main, or one of the main benefits here is that you don't have a shop floor vision box anymore, because the IDS NXT cameras do the processing themselves. There we go to a monitoring level. Here, for example, our cockpit provides multi-camera monitoring functionalities. So beyond what the control uses to steer the process, you can even have a look at what the camera, what several cameras themselves are doing at the moment, looking at different apps and different tasks they do. And beyond that, you have a data center or cloud level. And as mentioned here, our lighthouse comes into play, because especially with the deep learning tasks, you usually want to accumulate interesting images also while the application is running. You upload them to the training facilities in Lighthouse, and then you can refine your models. So now, going back to the lowest level, I want to focus in on the question, how do you now make the camera do what the application requires, not only run a network, but also provide some logic. So we have, since a longer time, available the programmer tool here. That's our Vision app creator, open platform programming. So you program against our NXT API. You have full flexibility. We provide you an IDE with a virtual environment. And you basically use your custom modules and do free programming from scratch. Clearly, we provide some examples for that you can start with. And this is targeting programmers only, because you need, of course, the software development background to use that. So beyond that, this year, we have focused on making that process easier. That's why the title of my talk is Easiness. So we already have the Lighthouse cloud-based facility for dataset management, labeling, and training. And what we now focused on was to provide a way directly from our Lighthouse to build or pack a Vision app, including logic, to be directly installed on our cameras without the need to program or to develop software. And we have realized this with 2 entry points now. So you can now app your NXT camera without coding. And the first entry point that we offer is a use case assistant. So here, as shown in the screenshot, you think about an application like classification your parts or your image into an OK class or a not OK class. Then you can just select this use case, and you create your Vision app to be employed on the camera or deployed on the camera step by step. So this is a wizard, as we know it. And besides that, we want to also open up for, let's say, non-standard workflows or more complex workflows. That is our approach with the block-based editor. This is based on Google Blockly. And here, as you can see in the screenshot, you have modular blocks that go together nicely, like a bit like a puzzle. And you build your own program logic from loops, AI inference tasks, and so on and so forth. So this is a very flexible approach, though without the need for any coding on your side. In the next video here, for the next minutes, I want to show this, how this works in Lighthouse. So here, this is our cloud-based AI Vision Studio. Logging in selecting Vision app creation, we'll start the process, and then we focus on the block-based editor for now. And as you can see, for the Vision app, this is something that you individualize usually. You build it for a specific purpose. In this case, it's a presence check of screws. You can give it an icon to easily recognize it in the management system. And from there on, you start with initialization, and you build some logic for your program from blocks just by, let's say, drag and drop here. In this case, in the first part, it's about setting the camera module up, like want to use free run or some exposure time variation and so on. And then here, we construct the first AI task. So this is only one block needed to do a classification. However, the camera needs some information for that, so we can provide it some sample images. In the cloud, we have access to all our training data, so we can easily test out with our training data set. And we have access to our trained neural networks from that and give them useful variable names to be used in our block program. So that's happening here. And when we now go back to the program, we can select this neural network. And at this point, actually, this is an application doing the inference and spitting out results. So initialization will take a while, but now you can see on the lower right-hand side, the network gives already an OK or NOK answer, and also provides more information about ROI, probability, and so on. So now this program is really very basic because it doesn't show anything or doesn't provide an interface to the results yet. So this will now be fixed or extended by 2 more blocks, which provide result nodes. In this case, it's just the image. So you can see these are small images of a thread hole, different backgrounds, and so on. And the network just says OK if there is a screw here, or an NOK if there is no screw there. And in this case, we omit the initialization, but now at this point, we already have a Vision app ready that can be packed. And in the next steps here, we just build and download this Vision app from the cloud or from the browser and put it on our camera to make it run there. So this goes a bit faster than I did it, of course, because I do not want to extend my time today. Here we're looking at the camera. This is password protected. And the camera has an app management setup. So here we have different Vision apps. We just now upload the one we just created, install it here. Takes a few seconds, and then we can make it run. And now we see basically the app view in our cockpit. So always the image, and then the inference results on the bottom. And this is, since this was running live, I could also change the situation and check how this is doing with real images. And now a nice feature of this is also, this is now on camera. Our web server also provides the block interface on camera. So if the app already runs, you want to add something, change something, you can also there just add some more features. And here in this example, I just switched the result because having the JSON structure is nice for information content, but for just viewing it, it's not so easy to see. So this makes it a bit simpler. We have blocks for that. And if I run the application again now, you will just note a small difference, namely that on the lower side, the result is just written as one string. Maybe that is all I need for each image. And that's about it. So this shows how easy it is from the cloud, basically, to construct a Vision app and bring the functionality on the camera. In this case, it was simple, just classification and showing the result. Of course, with Blockly, we have many more possibilities to do. So I come to my summary here. We now have 3 options to put vision functionality on our NXT hardware platform. I mentioned on the right-hand side the Vision App Creator addressing programmers that have full flexibility, coding, compiling, custom modules, and so on. Here we serve, for example, companies that put their solutions on our Vision Pier. And on the left-hand side, you see the two new access points, use case assistant, so be guided by a wizard for a specific application. Or in the center, our block-based editor. You've just seen in the video how that works. The access points here target on, so the use case assistant mainly focuses on people that can use their domain knowledge on their specific vision problem and to learn the AI workflow without having to learn the AI background. And then in the center, block-based editor, of course, you can use it from quick evaluation to complex logic. Right-hand side programming, as I've mentioned. And with this, I'm already at the end of my presentation. So it remains for me to say, to invite you to our booth. As said, it's just visible from here, to look at our new platforms, new things, and discuss AI vision with you. With that, I thank you for your attention.
Thank you. So any questions to Martin? Who's got the first question? No? Okay. I have one. Maybe a bit of a stupid question, I don't know. But just imagine somebody has never used a machine vision system and works in a manufacturing setting, and somebody says, we bought the IDS NXT product, and we would like you to qualify to use it and to operate it. How much training would that need for a simple, maybe, machine vision task to make the operator being able to use this? Are you going into democratizing machine vision, making it usable for everybody? Low barrier?
Actually, yeah, yes, that's one of our goals, to lower the entry barrier as much as possible. So of course you need some domain knowledge on the problem that you have and whether this is in general a problem to be solved with vision and or AI tasks. So you need to know a little bit about classification, object detection. And then the main work that you do in bringing such an app to run, to work, is of course working with the image data. So you need to get a feeling for what information in your image is useful, how to make useful images, and so on. Because the training for this process takes a bit longer than I've just shown you. But from there on, if you have a rough idea, it will work. You can get to a proof of concept. I would say, or colleagues told me that are not working in vision like I for many years, let's say within hours, you can have a first app or a first classification running. Usually, you will accumulate then more data and so on. So it take, let's say, 1-2 days to have something like a proof of concept.
So very quick to learn.
And with a focus on the images and not on the deep learning, let's say, technology.
Yeah. Thank you. Any more questions? That's not the case. Thank you very much, and Martin.